Good morning, guys. Today is kind of yeah, it could be kind of complicated to understand. Uh, we we are learning about circuit, right? And we finished the inductor and capacitor. You know what I mean? Separately, right? But actually, in our power system, it has to be together. R, L, C. It gotta be together. It exists in the circuit together. You know what I mean? So they cause transient response. You know what I mean? So if we understand that this, also this is the same meaning of principle of switching surge. Whenever we switch it, turn and off, the current is surge. You know what I mean? So we'll also learn about it. So let's move on. So first of all, I guess you guys may see this graph, or this picture, right? So overdamped and underdamped and critically damped, we will learn about it. First of all, I'll explain about something. First of all, look at that quick review about RLC. So L, C. In a DC, steady state, L is a short circuit, right? And C, capacitor is an open circuit, right? And so, which means, yeah. So L is, it prevent or interrupt the sudden change of the current, right? So current. And C is same purpose, but Y means it prevented the sudden change of voltage, right? So it could be here, this section. This section is transient state, and this is a steady state, right? So we learned about it here. So what I mean is, for example, our power system is, look at that here, generator, R, L, and this is a C. This is we say also earth capacitance or line capacitance. I will, little bit explain about this. But now we don't need to about it. Just memorize about our power system. There's RLC, okay? And for example, this is load, right? Load. So this is our general circuit, right? But what I mean is here, look at that. Let's move on a little bit. Here, this is for example, transmission line. So now we don't need to deeply know. We don't need to know deeply about what is the earth capacitance or light capacitance. We don't need to know about it right now. Okay, just understand. There's exist this, So for example, because of that earth capacitance or line capacitance, there's pros and cons. For example, good advantage part is, it improve our power factor. You know what I mean? But disadvantage is it makes a surge of voltage. You know what I mean? And for example, penalty factor. Now we don't need to know about it, but there's a pros and cons about in the earth capacitance or line capacitance. Where is it? Oh yeah, here. So what I mean is generally, for example, here's if here's 100 amperes, coming through here, But generally to here, almost, for example, it's 1.1 ampere, 0.1 amperes follows here. And the other part is 99.9 amperes coming through here. So we could ignore this circuit, you know. In the we have a load system. But what I mean is, if we don't have a load or it happened like short here, you know, no load system, like for example, here's open circuit. So at the time, RLC is, circuit is working, right? But for example, it's closed to the load or the short is not happened. So to here, the capacitance to follow the current is very small, right? So we could ignore it, right? Yeah, but at this situation, it happened. We say transient response, okay? So to understand this part, first of all, we need to know about what is L, what is C. And as you guys know, C is connected to the voltage and L is connected to the current, I, right? So let's move on. We will, get the example about the physically, physical, yeah, for example, I'll make a physical example. Okay. So we know about this, right? But that's really important to understand this part. Look at that. Here's the weight, right? But first of all, we know that if it's here, there's no energy, right? Energy is 0. I will say this is A, B, C point, okay? So at first time, there's B point, so energy is 0. But if I use my hand, this is, for example, the weight, the blue ball. If I use my hand to here, which means now it has energy. We say potential energy, right? And if I let it go, for example, it's connected with the string, right? Let it go like this, right? It have to be what is that? Vibration, right? Swing, right? Like this. But for example, now it's a potential energy, but it moves to the kinetic energy when it moves, right? And when it reaches the A point, also it has a potential energy. So which means two different energy, kinetic energy and potential energies, swing. So what's relevant to the our RLC, LC is transient response. What's the relevance? Here's look at that. You guys, as you see here, we know we learned about the LC, right? L is, I said, connected current or magnetic, right? Field. But C is connected voltage, right? As you guys know, voltage is a potential energy, right? Potential energy, right? Some position energy, you know what I mean? So which means the potential energy is what was it? A, no, mgh, mass, gravity, height. You don't need to know about it. This is a physical, okay? So potential energy means, mass, how much, it is, like gravity's acceleration, you know what I mean? Like how much it get more faster like that. And how much, how tall it is, like height, you know what I mean? So which means potential energy. But kinetic energy is kind of a different energy. It's a moving energy, right? So 2, 1, and 3, 2, 2. This is kinetic energy. But what I mean is it's kind of relevant, is it? L is current, right? Current is electrons moving, right? So kinetic is also moving something, moving energy. So this is the same concept to understand this. And capacitance is voltage, right? Voltage is potential energy. So potential energy and kinetic energy. So look at that. So if they are together, two different energy, we use like that. It's a have to be happened vibration or swing, right? Now we say it's swing, but in electrical, circuit we say vibration happened, or it's a swing is also doesn't matter, just the same meaning. Okay. So what I mean is here's for example. Look at the guys. Here's you guys can see underdamped or overdamped. You guys can see, right? Overdamped is, we could just think like we have a circuit like RLC, right? R is resistance, right? So if it has a, kind of a strong, like for example, overdamping means, if I said the RLC circuit or, from potential energy to kinetic energy, it has to be swing, right? But overdamping means, we just I wanna stop it because I have enough resistance. So don't swing. You know what I mean? Don't swing. Stop here. But underdamping is, not enough the resistance. You know what I mean? So that's why it gotta be swing and slowly like down. I'll show you one more time. Look at that. Here. Okay, picture. Look at that. So there's A, B, C point, right? So from here, C, right? It has a potential energy, but overdamping means, it has to be like that, right? But because of some reason, that's some reason, because of the, kind of a big resistance, it just stopped here, which means overdamping. And so from C to the B, directly just stopped. But what I mean is another damping I mentioned is under damping, under damped here. Why it doesn't move? I don't know. Sorry about it. Yeah. So it has to be like A point, C, and little bit, like, and they stopped to the B point. But what I mean is, in our power system, we has to be, generally, we has to be a under damped system because our main purpose is, to we don't want a loss of too much current, right? That's why we need to reduce the resistance in the circuit, right? So it has to be, yeah, under damped system. Yeah. Yeah, that's it. Today I wanna explain to you guys everything. Yeah. If you guys have any question, let me know. Okay. Oh yeah, sorry, I forget one thing. So which means, this swing, as I mentioned here, this swing I mentioned here, right? It's in the circuit. If it's happened like it's the same meaning of switching on and off surge. You know what I mean? On and off switching surge, happened. It's the same meaning. So soon we will learn more about the switching surge. Okay. Yeah. That's it today's lecture.